Hello everyone, welcome to week 10 lecture. Our today's topic is multivariate statistical analysis. You know, in the last few weeks we have been discussing different statistical techniques. So far we covered univariate statistical analysis, bivariate statistical analysis. Today we will be covering multivariate statistical analysis. We will cover chapter 24 today, and we have 5 learning objectives. So first of all, we will discuss today what multivariate analysis is, or when multivariate analysis is suitable. And then we will be discussing different multivariate statistical techniques. For example, multiple regression, multiple discriminant analysis, factor analysis, cluster analysis. So we will be discussing them, though our main emphasis will be on multiple regression analysis. And as usual, since there are 5 learning objectives, I will be uploading separate videos on each learning objective. And in this video, I am discussing learning objective 1, what multivariate statistical analysis involves, and different types of multivariate analysis. So first of all, what do we mean by multivariate analysis or multivariate data analysis? So far, we already know multivariate analysis involves multiple variables. That means if you have a research hypothesis that involves an analysis of multiple variables, then we use multivariate analysis, or we use multivariate techniques. So multivariate analysis or multivariate technique involves multiple variable or multiple set of variables. Let's take some example. Let's say you are measuring what determines employee satisfaction. Now, employee satisfaction is one variable, and there are some determinants. Maybe professional training facilities, or maybe facilities to move upward in the profession, maybe other facilities, or options for vacations, and so on. So as you have these different determinants of employee satisfaction, and your dependent variable is employee satisfaction, you will be using a technique that combines this variable to answer your research question. This is an example of multivariate analysis. Now, what do we mean by the term variate? Variate actually is a mathematical way of presenting an equation involving multiple variables. So in a variate, what we actually do is we present one variable as a function of multiple variables. So that represents a linear combination between these variables. For example, if you look at this equation where bk is a variable that is presented as a function of variable x1, x2 up to xm. So this is an example of a variate. Now let's take a very clear example. Let's assume that we are measuring employee satisfaction with 5 questions in our survey. That means we are conducting a survey. We are asking our employees 5 questions that will indicate their overall satisfaction. As I said, probably we will be asking that whether they are happy with their salary, whether they are happy with their leaves, whether they are happy with their development options, or whether they are happy with their training facilities. So we will be asking 5 separate questions. Now we present a variate in this way, VK. This is the overall employee satisfaction. Now x1, x2, x3, x4, and then x5, they are 5 questions that I'm talking about. So you understand that each of these 5 questions, x1, x2, x3, x4, and x5, each of these 5 questions contribute to understanding this overall satisfaction. And this L1, L2, L3, L4, and L5 is sort of regression coefficient that we discussed last week that actually indicates the strength and direction of relationship between each of these variables with these overall satisfaction. For example, if x1 is a variable like salary level, now L1 will indicate how strong the relationship between this x1 and vk, and what is the direction of this relationship. Okay, so and this is an example of variant. Now, there are basically two types of multivariate techniques. One is dependence techniques, another is interdependence techniques. So, put simply, when we are talking about dependence techniques, we have to have at least one dependent variable. That means if we have multiple variables and if we can find out that among the variables we have at least one dependent variable, then we will be using dependence techniques. So we will be describing or explaining the dependent variable with the independent variables. So different types of dependence techniques are there. For example, multiple regression analysis, multiple discriminant analysis, multivariate analysis of variance, and structural equation modeling. We won't be discussing last two, that means multivariate analysis of variance and structural equation modeling. Now, it is not the scope of this course to discuss two. We will be discussing this multiple regression analysis and multiple discriminant analysis. And then interdependence techniques. As I already mentioned, that all the multivariate techniques can be divided between dependence techniques and interdependence techniques. In dependence techniques, as I mentioned, that there will be at least one dependent variable. Now, if you have multiple variables and if you cannot find out at least one dependent variable, that means all the variables are interdependent. There is no clear out a single dependent variable, then we use interdependence techniques. So in interdependence techniques, we do not explain one variable with the other. Rather, we try to give meaning to each set of variables. Different interdependence techniques are there. For example, factor analysis, cluster analysis, and multidimensional scaling. We will be very briefly discussing them today. So how do we find out which multivariate technique we should use? So first question we need to answer to determine what multivariate technique we use is, does at least one dependent variable exist? If the question is yes, then we will use dependence method. If the answer is no, then we will use interdependence techniques. Now, which technique we use, that also depend on the measurement scale of the variable. Measurement scale of the variable means whether the variable is a nominal, ordinal, interval, or ratio scale. For simplicity, we will divide these four scales into two. Nominal and ordinal scale will be called non-metric, and interval and ratio scales are called metric. Nominal and ordinal are called lower level scales, and interval and ratio are called upper level scales. So again, I say nominal and ordinal are lower level scales and called non-metric, and interval and ratio are called higher level scale and metric. Now, if we extend that, so how many variables are dependent? That's the second question you need to answer. If there is one dependent variable, then you need to answer a question that is it a metric variable? I mean, your dependent variable is metric or non-metric? If your dependent variable is metric, I mean interval or ratio, then you should use multiple regression analysis. Whereas if your dependent variable is non-metric, you should use multiple discriminant analysis. Now, if you have more than one dependent variable, once again you need to answer the next question is, are they metric or non-metric? If they are metric, then you should use multivariate analysis of variance. And if they're non-metric, then you should use conjoint analysis. And if there are multiple independent and dependent variables, then you should use a structural equation modeling. So as I already mentioned, that we won't be discussing this multivariate analysis of variance, conjoint analysis, and structural equation modeling. We will only be discussing these two, multiple regression analysis and multiple discriminant analysis. So this is the end of this learning objective. In the next video, we will be talking about multiple regression analysis. Thank you.